All right. So next up, we have Shaun McCullough. And Shaun is a friend of mine. We met through the SANS Masters program. We've even had a couple virtual happy hours to help cope with the whole COVID lockdown. And we worked together on a variety of different group projects and so forth. So Shaun got his computer engineering degree from Virginia Tech, and then, of course, his MSISE from the SANS Technology Institute. Shaun is a technical director of red and blue operations for a government contractor, or government agency, I should say, and then is also a consultant with H&A Security Solutions. So I'm very glad to see that Shaun presented this topic for our audience. So with that, I'll let Shaun take it away.
Thank you, Ken. Appreciate it. Before I start, I got to tell you a little story about how I actually met Ken. We were both in the master's program at SANS at the same time. And Ken, I think it was like 5 years ago, maybe, we were both part of a group project. We got thrown together. We didn't know each other. And it was a 30-day group project where we had to come up with a whole process for how an organization would move from on-prem into the AWS cloud, right? I mean, it sounds familiar. A lot of us do that. We had to come up with cost analysis and a management plan, security plan, of course. And also we had to demonstrate how you would build and destroy and operate the actual applications from this, this fake company. And I remember one night, Ken and I are trying to debug this script that I broke. And I was like, man, Ken, this is a lot of work for this class. I'm just surprised that SANS is having us do that. And that's when Ken tells me that what we were doing for this project was actually his idea. He had pitched the idea for moving a fake company to the cloud. And so all the work was his fault. But, Ken, I got to tell you, I'm really thankful for being on that project, because not only did I get to meet you and became friends, but I really did learn a lot. It was one of my favorite classes that I had in SANS. It kind of brought me to this topic today. And it's one of the things that we talked about when we did that class was, if you are building, if you're figuring out how to move into a cloud environment, you're probably spending a lot of time trying to figure out what applications do I just lift and shift, and which ones do I actually have to rework somehow. And we talk about the applications in S3 and Lambda and all this really cool stuff, but we don't talk about the infrastructure we use to manage our virtual machines. A lot of times we just lift and shift that. We just do what we've been doing on-prem. So what I wanted to do was talk to you guys about how maybe you could approach VM management in the cloud a little bit differently, and in a way that not only will improve your security, but maybe give you some new operational capabilities that you didn't have before. And one of the reasons why this is such a big deal is because if you've ever worked in IT operations, it takes a long time and a lot of manpower to manage the patch cycle process for a virtual machine. If we were live right now, I would ask you, how many of you have done this kind of process? And a bunch of you would probably raise your hand, and it would be very slowly, because it's a very sad, difficult thing that you have to do. I've done it, I know it. And the reason is because we go through this process where, on the slide here, you look, we start at 12 o'clock at discovery. It's Patch Tuesday. There's a new patch that's come out. We've got to deploy it to all our environments. All right, so first we're going to inventory our environment. What systems need to be patched? Which ones have to be off limits because of other reasons? We analyze those patches, and then we plan for how we're going to do the deployment. Then we implement the patches, and 10% of those break, so we got to remediate them somehow. We validate it works, and then we report back. And then we just do the cycle all over again, and it's frustrating. At the end of the 3 days, 2 weeks, however long it takes in your organization, you've got virtual machines. I mean, you have the same thing you started. There may be a little bit more secure, and that's great, but it's still the same thing. And I kind of look at it this like when I had to get a new roof put on my house. There was a bunch of shingles that had blown off during a storm, and I had somebody come out and they said, yeah, it's a new roof. And I remember writing a check and going to work. And I remember coming home that evening, driving into my driveway and looking up and like, oh, it looks like a roof. Like it looks like the same roof I had before, even though I wrote this check. It wasn't exciting like a new TV or something like that. And I kind of feel like that's what happens with our patch management process. So what I really want to do is figure out, can we speed this up? Can we make it more operational capable in the cloud, and even make it so that we add some, operational security and business processes to it that we couldn't do before. So I'm going to walk through a 4-step pipeline, or 4 steps that you take to build this pipeline to manage and run your virtual machines. Normally in a talk like this, I would start with step 1, then 2, then 3, and I end at step 4. But today I'm actually going to tell you the end result, because I just feel like we need to know where we're headed. And so I'll tell you what step 4 is, then I'll jump back to step 1, and we'll go back through the process. All right. So our end result, what we want to be, what our big reveal will be, is that we want to be able to redeploy every one of our production virtual machines every single day. I know I lost some of you there, right? I mean, that's like, why would I do that every single day? All of my virtual machines, I can't do that. All right, so how about this? Instead of all your virtual machines, how about we throw off the database virtual machines, right? Or how about we just focus on web applications and computational systems, Docker clusters, certain things like that. And maybe not every day. What if we did it every 3 days or once a week? It doesn't matter what that frequency is. What we want to be able to do is be able to deploy them at a moment's notice, and do that so that every one of them, every time they're redeployed, they're as secure as possible, and it's cheap and easy, and we don't actually have to think about it. That's really what our goal is. All right, so that's our 4-step. Let's go to step number 1. First thing we have to do is we got to start with a solid baseline. We've got to figure out where there are virtual machines that are out there that we can start with, that we know are relatively safe, and they're not going to change a lot underneath us. Like they're pretty stable. So that's what we need to do. There's really 4 places in where we can go and look for these virtual machines. The cloud service provider gives you a set of virtual machines that they are either managing, or they have provided some kind of some kind of process in place where they say, yeah, these are virtual machines that we approve and we think you should use. Amazon, if you go in and create an EC2 instance, you'll get a list of AMIs that you can pick from. There's the Amazon Linux version. There's a CentOS and an Ubuntu and some Windows and some things like that. So you could use the cloud service created and provided virtual machines as you need to. The major service providers also have a marketplace. And the marketplace is where you'll have companies come and say, here's a virtual machine. And usually they've got some kind of application attached to it, right? So they're pitching some product that they run, that they want you to buy, and they'll provide you the virtual machine already configured to use it. So you could go to the marketplace and get those virtual machines if you trust the company that you're buying it from or getting it for free from. It's up to you to make sure that system is good. Microsoft, Amazon, Google, they're probably only doing cursory evaluation of those marketplace virtual machines. Mostly they're just validating that the company will pay them, really is what it is. You could also go and get a virtual machine that is just shared, and you don't know who it is, but you can go and search for these virtual machines that are out there put out by strangers. This is a bad idea. I would not recommend doing this. It's possible if you know who the person is, if it's from a company that you are working with, or you feel like they are safe and they're secure and they have a standard baseline that's not going to change out from underneath you. But you can use that sharing process. But I really wouldn't recommend doing this unless you know who it's coming from. Fourth, you know what? Let me say this about that. If you are, let's assume that you're part of the security team and you're managing infrastructure that your dev teams are pushing out there for your products. If you are hosting and managing a node-based application, 60 to 80% of the code that you're serving was not written by your dev team. So you're already using software and tools from people that you just don't know who they are. But I don't recommend you do that with your virtual machines. Okay. Fourth place you can go to is on-prem. You could build your virtual machines, build an image, package it up, and import it into the cloud service companies or into the cloud. So the 3 major ones have the ability to do this. It's fairly easy. If you already have a process on-prem to do that, use the same virtual machines on-prem and in the cloud. You could definitely do that. All right, so we have this baseline, and we're going to go from left to right on this in this pipeline, excuse me. And we start off with our baseline. So in this particular company, they're going to have Amazon's Linux version 2, some Windows Server, CentOS 7 and CentOS 8. There's 2 different dev teams, and for whatever reason, one of them can't use 8 and they'll use 7. There's an Ubuntu version, and then some strange thing from the marketplace. You got to make sure that these are fairly secure. They're probably not where you want them to be. That's our next step. But you got to make sure that they are pretty stable, that they're not going to be, you know, libraries you depend on that'll be ripped out of them the next version that's released from wherever you get these from. Okay. All right. That's our first step. First step is to start with a solid baseline. The second step is we want to use some kind of orchestration service to patch and prepare these to be given to your development team. Here's what I mean. We're going to use an orchestration service. Ansible, HashiCorp's got a couple products you would use. The cloud providers have some. I'm actually going to talk about one at the end of this from Amazon. Chef, Puppet, you know, whatever it is. It doesn't really matter so much. A bunch of scripts that are cobbled together. You could use those. But you want to take that baseline virtual machine that you've gotten from your provider, and I recommend that you patch it, and then patch the operating system, patch all the standard libraries, install anything that is required from an IT operation or security purpose. So if you are required to follow the CIS benchmarks, apply those benchmarks. There's code out there to do that. If there are certain security policies that you're implementing, you can do that here. So for instance, logging has to be turned on, or you have a host intrusion detection system that has to be installed on all your virtual machines, or maybe all your Windows virtual machines. You can do that at this point. And then what you'll do is you will spin up your original virtual machine that you got from this, you know, from wherever you're getting it from. Let's say the Amazon Linux 2. You've spin up to an actual running virtual machine. You apply your patches, your CIS benchmarks. You delete users that you don't want on there, whatever the preparation is. And then you take a new snapshot. Now you have a snapshot for your dev team in which they can safely build whatever the application is that they're building and hosting. They can build off of that secure new image. So it would look like this. We start on the left-hand side with our baseline image. The gray here is spinning up a virtual machine, running some scripts to install patches, install host intrusion detection systems, whatever it is, and then creates a snapshot and makes that available to your dev teams so that they can take it and implement their code on top of it. All right. So that is our step 2. Step 3, the third thing you might want to do, you would definitely want to do, is you want to build a new image that's not being deployed maybe, but is deployable. There's a big difference. This is where the development team would take that image and would install, let's say the dev team is for the marketing team, there's the web developer, and the web developer is managing the marketing website, right? We'll just use a simple case there. They would install Nginx, they would set up configurations, they would do additional things that has to be done. They'll drop the marketing website maybe onto that virtual machine, and then they create a snapshot. So the dev team is installing application-specific libraries and configurations, and possibly the code to run it. The reason I like splitting it up between the two, and we'll do links page. The reason I like spinning up between the two is that your dev team is probably going to change the code fairly often. And it may be faster than you're changing you would patch the systems. So they would always be able to, in the yellow here, they would always be able to take a new snapshot from the standard secure IT approved image and be able to test their code on it. And they would be able to run it through their automated testing. Hopefully you have the automated testing. And they would be able to test it and say, yeah, this is actually going to work. If there's a change that happens to that those gray systems, it's probably a patch. It's probably nothing significant in terms of that would mess up the development team. That is the hope. The dev team is usually different than the operations team. But even if you're the same team, I recommend breaking it up this way, because you're probably going to have a person that's more focused on the security of the systems, and someone that might be more focused on deploying the code. And since there's two different people, you could even split them up this way. Also, what you're doing is you're probably going to have multiple teams grabbing from the same virtual machine. So if we're going to look at, like, the Linux 2. So there's a Linux 2, Amazon provides a Linux version. You've patched and prepared it in the gray, and then you've got two different teams that are making use of it for whatever their product, whatever their application is. They know they're always pulling from the latest. Now, how often would we run these patches? We could run them all the time. I mean, it's just code. So going from the blue to the gray, we could run it every day. We could run it every hour. It wouldn't really matter. The idea, though, is that you're writing these scripts and you're writing this code so that they're installing the applications, the configurations, the logging, whatever is needed, and then can be easily tested. You want to make sure you do that. Once you've deployed once your dev team has taken that code, they've built it, they're going to create a new snapshot. And what you've created is a deployable system. Amazon, Microsoft, Google, these cloud providers, they are really built around this idea of elastically creating having an environment that you can easily and elastically grow the virtual machines and shrink them at a moment's notice. In an on-prem environment, you probably were building let's say you have an application, it's a web app, and between 10 a.m. and 4 p.m. is when all the heavy use is. So you deploy a virtual machine that will handle that max load, and then it just runs like all night. So at midnight, it's the same size system. You don't really want to do that in a cloud environment because you're paying for that, right? So what you really want to do is, instead of having one gigantic virtual machine running your web application, you have multiple applications or web applications running on multiple virtual machines behind a load balancer. And you use something called an auto-scaling group. And I'm using Amazon terms, but they're very similar in Azure and Google. But that auto-scaling group will spin up those systems when it knows it needs to and spins them down. It does that by going and grabbing a virtual machine AMI or whatever the case in Azure. But they're grabbing that virtual machine from somewhere that's ready to go. But we saw in our pipeline that we can deploy those virtual machines at a moment's notice. So our auto-scaling group is going and grabbing it. With this process, if you have elasticity, if you've built this for elasticity, you could scale up rapidly and scale down really easily. And you're always going to be scaling up with the most recent system. But you never have to patch that live system. Let's say that process we were looking at, we run this every hour, maybe going from blue to gray and then gray to yellow. We could run that on an hourly basis that's automated. We could run it on a daily basis. However often it runs, that is the system that is at the most recently patched. So you may never have to go patch a live system again. So that whole loop we were going through before, where we're trying to figure out, all right, what's out there? How do I, what do I do with it? How do I patch it? What happens when it doesn't patch properly and remediate? We don't have to do that whole process anymore, at least for patching and updating. We're taking advantage of the provider's elasticity. And because we're taking advantage of the provider's elasticity, we can do things we probably couldn't easily do in an on-prem environment. If suddenly there's a big, it's the holiday rush and a lot of people are hitting your site, it's fine. Your system is built to elastically go up and down. If you find out there's a major vulnerability in your code that's been deployed and you've got to fix, you can go out and destroy all the currently running virtual machines and it will reload it with the new one that you've patched. You can destroy and redeploy on schedule, or you could have just let the cloud provider elastically grow and shrink. So in production systems that we're running, they'll spin up and spin down during the course of the day. It always will destroy the oldest first. So in a 24-hour period, most of our virtual machines have been reloaded anyways, at least in 3 days. We've rebuilt all of our virtual machines. So now some interesting things come up. If I don't patch a live system, do I need to actually SSH into it ever? Maybe not. Maybe if there's debugging or remediation, but certainly not for daily maintenance. Maybe you never have to do that again. Do you have to scan a live system? You might have to because you're you're required to for whatever reason. But if you have systems that are growing and shrinking at a moment's notice, you never have to really patch a system because you just destroy it and build a new one. Maybe you don't have to do vulnerability scans on a regular basis. So we've gotten to the end of our little pipeline here. We've taken from our baseline here on the left-hand side. We have built some kind of code that is going to patch it and prepare it for the development teams. This is where we can codify our security policies, which I love that idea when we talk about things like infrastructure as code and how we can leverage that in the cloud. You now have teams that can say, this is the security policy, and we implement that at the infrastructure level. You have your development teams that will grab the gray box, so the gray AMI, will implement their own code on top of it, and then prepare it and provide it so it's available for your auto scaling system, which is I guess that's orange on the right-hand side. And now Amazon or Google or Azure can take those AMIs, spin them up, spin them down based off of the need. And you now have this elasticity you've built into the system. You don't have to patch it. You may not have to do much remediation, which may reduce your threat on those systems itself, on those live systems. Makes it really nice. All right. A couple things you can do to simplify this, make this easy, because I spent, 20 minutes here kind of walking through slides. It sounds easy, but it's not. There's a lot of things that can go wrong when you do this. You're taking a lot of your effort and putting it in the front of your process. In the beginning, you're doing a lot of development and design and deployment and all that kind of stuff. Well, once it works, it usually is pretty smooth, assuming that your baseline images are pretty standard. I've had situations where I've used baseline images that were from another organization, and they made changes, and it blew me up in the middle of the day. But as long as your baseline images are safe and pretty steady, then it sounds like it could be easy, but you're having to do a lot of work up front. So here are 4 things that I believe will make this a little bit simpler to build and to operate. First one, I should read it. First one is we simplify the process where possible. One of the big problems you have in this, this fake picture here of this company, they've got a CentOS 7 and a CentOS Ace and Ubuntu and Windows, and each one of the gray boxes and each one of the yellow boxes is code, right? Someone has written scripts that do some kind of evaluation or some kind of installation, hopefully doing some testing and preparing. And any one of those codes, something can go wrong. So let's figure out how to reduce it. So this is a good time where you can go back to your organization and say, hey, it's going to be CentOS 8 or more likely CentOS 7 or Windows. I'd like to get rid of Windows, but let's say here's our Windows version. Here's our CentOS version. We're going to use Linux 2 for Amazonish kind of things. And then maybe there's some marketplace images that are very specific. Significant reduction in your amount of work you have to do in your pipelines does probably mean that your development teams might have to change their code. But they'll change that code one time to move it over from CentOS 7 to CentOS 8. But that'll keep you from constantly having to manage additional pipelines. So it actually works out in the long run. So simplify where possible. Another thing I recommend is to build monitoring and response to problems early in your process. I've had cases where we've built code, application code, pipelines, things like that. And we get to the end, we're like, okay, how do we know if it goes down? And we have to go back into the code and you have to add checks and balances. My recommendation when you do any kind of infrastructure as code, any kind of event-driven architecture design inside the cloud or any of this kind of stuff, you build your ability to monitor and alert and respond at the beginning. So if, let's say our gray boxes that we were looking at before, let's see, that's where I wanted to go. Let's say our gray box, let's say when we run our code here in the gray box and something fails, or maybe there's a failure at the testing of the developers. Maybe when they run a test, they see something, they can identify the problem right away before it gets to the orange all the way on the right-hand side in deployment. All right. I also do recommend offloading as much as possible to the cloud service provider. I realize a lot of people don't like that. I I've worked in a lot of organizations. I've seen a lot of organizations. They have awesome engineers. And they're like, I want to build this widget this way. And I know Amazon has a similar widget, but it's not as awesome. And what happens is sometimes you can end up managing this widget forever, and it's not really core to your business. I like trying to offload as much to the cloud service provider as much as possible, because you've already decided to go in with them. You're already paying them a fair amount of money. Using, instead of using Rabbit MQ, you use SNS and SQS is not a huge leap, and you don't have to monitor a lot of stuff. Or you don't have to build and maintain things. Same is true in this process we're talking about. Amazon has this thing called Image Builder. I will state this up front. I like Image Builder. It's interesting. I haven't put it into production yet, so I would assume there's some limitations with it. It's fairly new. But Image Builder is really designed to replicate each of our boxes here. The whole idea that I'm going to take the Amazon AWS Linux 2, I'm going to spin it up, I'm going to install a whole bunch of patches and prepare it, and then I'm going to snapshot it. Oh, and I got to test it too, and then snapshot it. And then if it fails, I have to alert somebody. You have to write that code. Like, that's something that somebody has to write. The Amazon has something called the Image Builder, which is intended to help you do that. And what you do is you create what they call components. And each component is really like a YAML file. And the YAML file will specify how to run some kind of scripting. Put specific code in there, like in this particular example, I have, hello, which is not a really good test, but you could do a command that does yum update, right? And that will run that command and will update the packages on that system. You could have one that installs Nginx. You could have a component that installs your proprietary code. It could go and pull more detailed scripts from S3 or your code repos, whatever it is, and it can build these. But what you do is you build a component, which is an individual installation, and you can also build a test, which is another component, which is just a testing of it. So I can say, here's my Nginx installation component, and then you can build a tester for that Nginx, and you can run those. The Image Builder will run those on a particular image, and if it succeeds, if the test succeeds, it will snapshot the AMI and alert. If it fails, it will go back and will give you an alert. You could take a whole bunch of these components and you put them together in a pipeline. So exactly what we were talking about before, each one of those boxes we were looking at before with the lines around them, you can implement that in Image Builder. Now, there were some nice things in Image Builder that are a little clunky to do, but it looks like it's what's possible in the future. You can set version numbers. You can see I have 1.0.0 for my snapshots. You can create the pipelines so that if a version gets updated, or maybe my code repo gets updated, it automatically kicks off a rerun of the Image Builder pipeline. And so let's say I've decided there's a new way I'm going to install my intrusion detection system for Linux 2. I could update my component here in the image pipelines that says, that makes whatever changes required. And Amazon, you can alert Amazon's SNS service to say, hey, if this happens, go and kick off a new version of the pipeline. It reinstalls. Now all the images that are out there ready for deployment has the updated intrusion detection system. This is definitely possible. It is some work. I mean, it's not easy, but it's definitely possible. All right. The last thing on here that I wanted to mention is I really do recommend that if you do something like this, you do it and you fail really quickly, and you learn from it and you keep building. It is, I always tell, when I teach Security 545, we always have this conversation about infrastructure as code and how much do we actually bring to infrastructure as code versus having people administer their environments. And I always recommend that, I always say it's going to take a lot of work in the beginning. It's going to take a ton of work in the beginning. But if you build it once, it's super easy to build 100 or 1,000 of them. That's the nice thing about the cloud and the services that are provided with the open APIs. Same in this case. Once you build one pipeline with one virtual machine, it's a lot of the same mechanisms. It's just maybe some different scripts. And so building one, figuring it out will make it easier for you to build. And then 20. Hopefully not 20. That's a lot, but at least as many as you need. So I definitely recommend failing fast and learning from it. I also recommend, and this kind of goes into the second bullet here of being able to monitor and respond quickly. You need to be able to monitor your build pipeline, identify if there's a problem at any point, and if there is a problem, you can remediate it before it gets to our step number 4. Just for a visualization here, go back to this. I have had cases where there was a change in the blue, and that broke the gray, which was fine. We were able to detect it. We could tell from our scripts that something was breaking. What was really bad is if we didn't catch it until it got to the orange, until it got ready for deployment, because now Amazon's trying to deploy an AMI that's failing, and it'll fail, and it may not detect that it's failing, but somebody can detect it's failing. Your customers might be detecting. So it's really great. It's really important that you have tests throughout the process, which is one of the reasons why I like the structure of the image builder. You could also do that with Ansible. You could do that with other tooling. Another thing I would recommend on this is I try not to do configuration at deployment time. So when we go to the orange part all the way on the right-hand side and your auto-scaling group is spinning something up, you could have the first thing it does is run a script to do an update. But it's doing that to a live system. And if it fails, it's failing in a live system. Also, if you're doing something like updating your source code, let's say you have an application, every time you deploy, you want to go get the latest. You have to have some kind of access to your source control environment, or maybe an S3 bucket. And now you have a live running production system that has access to S3 or your code repos. And that's not so great. It's really great to do that in the pipeline, create a snapshot of AMI. Now when that runs in production, it doesn't need access to all that kind of stuff. So that's why I do like the idea of having multiple snapshots in a pipeline in a row for those particular cases. All right. And that is the end of this. I think there's a couple minutes for questions. I think Ken let me know. But I do appreciate your time, and I will be hanging out in the Slack for half an hour or so, and I can answer any questions beyond the talk. Thank you.
Okay, Shaun, thank you. First question from Charisma. She says, I like the method. It's very practical. How do you think this approach is different in Azure or Google Cloud Platform?
So from Azure, like let's compare like Azure and AWS, probably not a lot, especially if you're not using Image Builder. You know, you're going to be using, I don't know, like cases. You could be running Docker containers that would facilitate the deployment. You might be using Lambda. If you're using Lambda in Amazon, you're using function as a service for Google or Azure. A lot of the work is in what are my individual components and how do I build the tests? And those can kind of easily translate. So I guess my point is, if you're multi-cloud, you could use Ansible or tools from HashiCorp. You can be multi-cloud. You don't have to worry about Amazon, Google, or Azure specific stuff. If you want to be using Azure specific stuff so you can get take advantage of all the eventing, then you definitely could.
Sounds good. Another question. At what point in terms of the number of VMs managed does the benefit for this automation exceed the effort to develop, test, and implement the pipeline?
Oh, that's a good point. So let me rephrase that, make sure I understand. So if you have one virtual machine that you're running out there, building that huge pipeline probably doesn't make a lot of sense. I don't know if there's a good number. I think the big deal is how important is your production systems? If you have to ensure that your production systems are up at all times, and you have to make sure that they can scale, you're gonna have to do some kind of automated script for your deployments anyways. Whether you have 1 step or 3 steps is really depending on the size of your team. I always recommend for teams, since I can't have a conversation with you about what your organization looks like, just try it and have a small team of 2 people kind of build one and see how it works. And you might find that you want 4 steps and 5 steps or 2 steps. It really kind of depends on your organization. I do recommend though is having some kind of decision over what is the IT security team's posture and what does their baseline look like and what the dev team's baseline. What would be great is if you can say for your organization of 10,000 people, every web server is deployed on Nginx on a CentOS 7. That is like the best case. Now you only have one pipeline, and every web service that's being run in your environment runs from that single pipeline. That's really where you want to try to get to it at all possible.
What about derivative images? So maybe you make your baseline image, but then you have 3 other teams that are consuming that, then adding their stuff on top of it. Have you had any dealings with that?
Yeah, I have. And I find that the more derivative images there are, the more confusion there is down the line. Some point, someone goes down the line, it's like, why are they doing that? And they don't know who to go and talk to. And if they want to make a change, they have to go back. So it's definitely necessary. It's depending on the size of your organization. But when you start having lots of derivatives, you probably start thinking about change control boards. You don't want to do that, right? You want to try and get out of that. I would also state, I didn't state this in the talk, but that process for virtual machines is also very viable for Docker images. So we do that with our Docker images. It's a very similar process. And there you have a lot of derivative images, and it gets clunky after a while.
So it seems like you could publish a base AMI, or you could use the script to build the base AMI and then add your derivative stuff on top of that.
Yeah. Yep. Absolutely.
So I have one final question for you, Shaun. What's the temperature there?
It's a little warm.
Yeah.
It's a little warm in my upstairs room. So yes.
Yeah. So Shaun took one for the team and he turned off his air conditioner for us.
Yes. Yes.
All right. Well,